Today we're going to look at solving surface area problems for a three-dimensional shape. So we have 5 different steps that we're going to do here. We are going to wind up relating the three-dimensional shape that we have to a two-dimensional shape in order to help figure it out, because that will help us be more able to break up the shape into shapes that we actually recognize, determine the surface area of each one of those shapes, and then add them all together in order to determine the surface area of the composite three-dimensional shape. In this problem, Gavin constructed a model building and wants to cover the outside with paper. How much paper will he need to cover the entire model? So step 1 is to determine how does the 2D and 3D models relate to each other. So if we take a look, we have rectangle A, and rectangle A is the bottom of the house. So we can see that it's joined up here with the two sides. So the two sides, front and back, and the very bottom of the house is going to be rectangle A. Rectangles B, we have 2 of them. So we have both of the sides. So we'll have the exact same dimensions because they both have the same height and the same length. So we only have one rectangle B currently, but keep in mind both of these are going to be rectangle Bs. Moving on, I have rectangle C, which is the roof. So I have one over here and one over here. So keep in mind we have the bottom, and then we have a side, and then we have the 2 roof rectangles. So right here we have the bottom, we have the side, and then we have the 2 roof rectangles. So again, even though I only have one C written out, this is also going to be a C. They're going to have the same dimensions. And then my last rectangle, I actually have as part of the sides of the house. So I have the front and the back of the house, front and the back of the house, which looks like a pentagon. But we don't know how to figure out the surface area of a pentagon like this. So we're going to go ahead and break it up into 2 different shapes. We have a rectangle, and then we have a triangle on top. So each one of the rectangles in the front, I'm going to represent with a D because they're going to be the same. The front and the back of the house are going to be the same. And then the final shape is just my triangle. So because I broke up the front and back of my house into a rectangle, and the top part is going to be a triangle. And again, those are also going to be the same as well. So now it's time to go ahead and fill in some missing dimensions. Keep in mind, this is my length right here, and it's going to be my length for all of these rectangles. If I look at the picture, I can see that my length is right here as well. Because keep in mind, this is the front of the house, which is 24. And then directly to the side perpendicular to that is going to be the length. So I can go ahead and I can write 36 inches in for my length. And I only have to write that in one time. Then I can go ahead and I can look at C. So C is going to be this right here, which we can see that both of the sides of the roofs have the same measurement, again, because of that little line drawn right there. I'm only going to go ahead and mark off the dimension in one of my rectangles before moving on to B. So again, I already have my length listed. The height that I have is 27 inches. And I don't have to worry about putting that for this B over here because I already have it once. Moving on to my D rectangle, which I'm actually going to put the information down here just so that I don't get confused later on. So for my D, I have, again, 27. And then I have the side going over here, which is just 24, which actually helps me to finish off A as well. So A, I have 24, and I have my 36. So now I can go ahead and I can move on to my triangles. My triangles, again, they have the same base of 24. But for my height, I have to figure that one out. So the total height of the house is equal to 30 inches. And then the height of just the rectangular portion is equal to 27. So if I subtract that out, I find out that the height is equal to 3 inches. So now I have all the information that I need. I have the information for my B rectangles, my C rectangles, my triangles, my D rectangles, and my A rectangle. Step 2 is going to be to remember what the surface area formulas are. For a rectangle, remember it's just length times my height. And for a triangle, it's going to be 1/2 my base. And remember my base is along the bottom, think base bottom, times my height. And keep in mind that my height has to be perpendicular to my base. Long, remember, rectangle A had 24 by 36, 24 by 36. And when I do 24 times 36, I get 864 inches squared. Again, remember, it's a surface area problem, so all of my units will be squared for surface area. For rectangle B, over here, remember that's the sides of the house. So now I have 27 times 36, which is equal to 972 inches squared. Rectangle C, which is the roof. So again, I have 36 times 13, 36 again times my 13 side, which gives me 468 inches squared. Moving on to the front and the back of my house, which are 24 by 27 inches, and that gives me 648 inches squared. But finally, moving on to my triangles, I have 1/2 my base, which is 24 times my height of 3, giving me 36 inches squared. In step 4, remember, I need to figure out the total surface area of each one of these shapes. So rectangle A only appears once at the very bottom, so the total surface area there is 864 inches squared. But now I need to move on to my other shapes. So rectangle B, I have 2 of them, so I need to multiply that surface area that I got for rectangle B by 2. And when I do that, I get 194 inches squared. For rectangle C, again, I have 2 rectangle C's, so I'm going to multiply that by 2 inches squared. I also have 2 rectangle D's. And finally, I have my 2 triangles, so I'm going to multiply 36 by 2 for 72 inches squared. My final step is to go ahead and find the sum of all of these surface areas for each one of the rectangles and the triangles. When I add up the surface area of each part, I get a total surface area of 5,112 inches, again squared because we have surface area. So Gavin would need 5,112 square inches in order to cover his entire model.